All right, so this may look scary, but it's really not. Let's do this first one up here, okay? Here's number one. Okay, first, we do what we always do. We find the parent chain. So here's a split right here. And if we go down, this is going to have 1, 2 carbons in the chain. Whereas if we stay horizontal, this is going to have 1, 2, 3 carbons in the chain. Okay, so this is going to get included in the parent strand right there. And then we have 1, 2, 3, and there's a split here. But this only goes up to 1 carbon up here, whereas this goes to 1, 2 carbons. So we're not going to use the one that sticks straight up. We're going to go ahead, these go into the parent chain, and up to here's where it splits. So we're going to continue down this way in the parent chain. And then we have 1 carbon here and 1 carbon here. So it splits. It doesn't really matter which carbon you use. So we have to number this parent chain. So the substituent gets the lowest number possible, the lowest carbon number possible on the parent chain. So that would be if we started here 1, 2. Now we have a substituent. Now this is a connecting carbon to this methyl group. And then the next parent chain carbon is 3. And that's going to be a connecting carbon to this methyl group. And then 4, nothing, 5, nothing. And then 6, here is a connecting carbon to this group. And what is this group? This has 1, 2, 3 carbons in it, right? So 3 carbons mean, and it's a substituent, means propyl, right? And look at that shape. It comes down and it opens up in a fishtail. So that means this has got to be isopropyl. And it happened at the 6th carbon in the parent chain. So we know we're going to go 6-isopropyl. And then to continue on in the parent chain, after that 6 connecting carbon, we have 7, nothing happens, 8, nothing happens, 9, nothing happens. Okay, so we know this is a nonane because it's all single bonds, so it's ane. All right, and let's go back to the start here. We have 1 carbon. This second carbon is a connecting carbon from the parent chain to this methyl group right here, and that bonds to the carbon number 2 in the parent chain. So this is just 1 carbon, so it's a methyl group. So we know at carbon number 2 in the parent chain, we have a methyl group. And then we go up here to carbon number 3 on the parent chain, we have another methyl group because there's just 1 carbon. So 3 is a methyl group. And then carbon number 4 in the parent chain, nothing happens. Carbon number 5 in the parent chain, nothing happens. And we already did that 6 isopropyl, and then nothing at 7, nothing at 8, nothing at 9. Okay, so now we need to alphabetize these. We have an I, or we have these 2 M's from the 2 methyls. Well, I comes before M, right? So we're going to start with the 6-isopropyl hyphen, and then remember these other ones are both methyl. So we're just going to list the numbers 2, 3, and then hyphen, and then we have to use the di to say there's 2 methyls, and then we just continue on with the rest of the name of the parent chain, which is nonane. Okay, so this is going to be what this molecule is. All right, so let's look at this next one right here. Here's number 2. So here is where the first part in a chain splits, and this, if we go down, this is going to have further 1, 2, 3 carbons at most in its own chain. And if we go horizontally on the left, this is going to have 1, 2, 3 carbons also. So which one do we pick for the parent chain? Well, we want to pick something that's going to give us the most substituents. So here is a substituent right here already. So we're going to pick this chain so we can include this as a substituent. So we have, if we follow this parent chain so far up to this split, now we're going to go over this way, and now here's another split. And if we go up, this is going to give us 2 carbons on a chain. But if we go horizontally to the right, the rest of this will give us 3 carbons on the chain. So the 3 carbons on the chain is what we're going to use for the parent chain because it's longer. Always use longer. Now, how do we number these? Well, we have to number them so the first substituent gets the lowest number possible. So if we go 1, 2, 3, 4, that would be 4. But if we started over here, 1, 2, 3, well, the 3 would be the lowest number for the substituent right here. So we're going to go with that. And then we follow the parent chain line up. And so now we're at carbon number 4 in the parent chain, and that's going to have some action to it. That has a substituent coming out. And then we're going to go 5, 6, and then here is 7, which is another connecting carbon, and that has a substituent coming out. And then 8, then carbon 9, and then carbon 10, and nothing goes on, 8, 9, or 10. So this is a 10 carbon long parent chain, so we know that's going to be a decane, right? And so now let's look at this first substituent coming off at the carbon 3 from the parent chain. This first substituent only has 1 carbon to it, so that makes it a methyl group. The YL, the ill, because it's a substituent. And so that is at carbon number 3 in the parent chain. So we're going to go 3-methyl. And then the next thing in the parent chain carbon is carbon number 4 on the parent chain. So what substituent does that come out from? Well, it's a 1, 2, 3 carbon substituent. So that means prop. And it doesn't have any twists or turns, or like it doesn't split itself. It's just a normal chain, right? Normal. So at this 4 on the parent chain, we're going to have a hyphen N for normal and a hyphen propyl group. All right, now let's move on down the parent chain. Nothing at 5, nothing at 6, but up here at 7 is another connecting carbon, and this comes out and points out, splits into 2 symmetrical other carbons with a total of 3 carbons, because we have the attaching carbon and then the 2 carbons that split out like a mermaid's tail, right? So we know it's going to be iso, and since it's a total of 3 carbons in that substituent, propyl. And that's going to happen at this carbon 7 on the parent chain, so that's going to be 7-propyl. isopropyl. Now we have to alphabetize all these substituents so we know in what order to put them. So now we're not dealing with the P for propyl because this is an I for iso. And remember, anytime it's dealing with the end of the chain, you don't separate it from the rest of the substituent name. And so I is the letter we're going to use to alphabetize this. So we have I. Over here, we have a 4-N-propyl. Well, normal, it just gets a dash just like sec or tert. So since it's hyphenated from propyl, we still are going to use this P to alphabetize. And now this 3 is just a methyl group. So no trick about that. That's just going to be M. So which is alphabetized first? Well, the isopropyl. So we can write it a 7-isopropyl. And then the next in line is a 3-methyl. And then -4-N-propyl decane. Okay, now the next one on the right. The first time it's with this parent chain is, well, actually wait, because this is split. This could be 1 or this could be an N. Let's find out. This is 1, 2, 3, 4 carbons. This is 1, 2, 3, 4, 5 carbons. Okay, so we know this is going to be longer. This is going to be the parent strand. And then we go on to this, and then it splits again. Splits right there, splits right there. But if we go down, it's only going to give us 1, 2 more carbons in a row in a chain. But if we go straight horizontally to the right, we'll get 1, 2, 3 more carbons. We're going to use the longer, so we get the longer parent strand as possible. Okay, so if we're numbering this parent strand, which is the shortest number of carbons to get to the first substituent? So it would be right to left. So here's 1, 2 carbons, 3 carbons, 4 carbons. Because if we were to come this way, 1, 2, 3, 4, 5, 6 would be the first. So this carbon number 4 in the parent chain is a connecting carbon with the substituent. And then we have carbon 5 in parent chain. Carbon 6 is another exciting place to be. And then 7, nothing, 8, nothing, 9, nothing, 10, nothing, 11, nothing. Okay, so we have 11 carbons in this parent chain. And the prefix for 11 is undec. And it's all single bonds. So we know this is going to be an undecane. Now, if we go to the first connecting carbon in the parent chain, that's number 4. And what is the substituent connected to this carbon 4 in the parent chain? Well, that's got this carbon connected to 3 other substituent carbons, right? Like a little chicken's foot. So the chicken's foot is tert. And since tert is a butyl, 1, 2, 3, 4 carbons, then you're going to want to put butyl like that. Okay, now let's go to the next connecting carbon in the parent strand, which is 6. And what kind of butyl group is this? This is butyl, right? 1, 2, 3, 4 carbons in the substituent. So it's a butyl group. And does it branch off anywhere in the butyl group? Nope, it's just a normal straight line. So that's N for normal. Okay, and I think that's it for this one. Okay, now let's go to this next one here. This is number 4. All right, so let's find the parent chain here. Here is a split right here. And there's only 1, 2 carbons on this side of the split, but there's 1, 2, 3 carbons on this side of the split. So we're going to take this side of the split as the parent chain. We always want the most carbons. And then here's more of the parent chain, more of the parent chain. Here's another split. So this has 1, 2, 3, 4 carbons on it. If we go down here, it's 1, 2, 3 carbons on it. So we're going to take the 4 carbon section right here as the parent chain. And now we want to number this parent chain so the lowest carbon numbers apply to the substituents. So if we go here 1, 2, 3, this would be carbon number 4 on the parent chain. So that would be a connecting carbon to the substituent right here. And then 5, and then 6 would be another connecting carbon to the substituent. And then 7, 8, 9, 10. All right, so we know that that 10 is going to mean decane. And now let's look at these substituents. So this 4 there's the attachment carbon in the substituent, and there's the end carbon in the substituent. So that's only 2 carbons, right? And 2 carbons is F. So this is going to be an ethyl group. And then let's look at carbon number 6 in the parent chain. That's the connecting carbon to this substituent. Here's the attaching carbon of the substituent. And then it comes down and has another carbon. And then it splits off, doesn't it, into 2 other carbons going in symmetrical directions. And that's mermaid tail. So this has 1, 2, 3, 4 total carbons in the substituent. And it happens at carbon number 6 in the parent chain. But it's got this mermaid tail. So not only are we going to know that it's butyl, because it's got 4 carbons, but we know it's an isobutyl. So now if we alphabetize those, we're going to be comparing E and I to alphabetize these substituents. Okay, so now let's go on to number 5 here, and let's look and find the parent chain. Here's a split right here, and this has 1, 2, 3, 4 carbons on this split, or 1, 2, 3 carbons on this split. So we're going to take the more carbons stretch for part of the parent chain. Then we keep going on, and here's another split. And this is going to give us 1, 2, 3, 4 carbons at the longest for the chain. This goes 1, 2, 3, 4, 5 carbons for the chain. So we're going to use the 5 carbons as the parent chain. Now we want to number this parent chain so the substituents get the lowest number possible. So 1, 2, 3, 4. Here's 5 is the first substituent. So this is the 5, carbon 5 is the connecting carbon on this parent chain. And then we have 6, and then 7 is another connecting carbon on this parent chain for another substituent. And then 8, nothing, 9, nothing, 10, nothing, 11, nothing, 12, nothing. So by the way, a 12 carbon parent chain has the prefix dodec. You know, like down here, 10 is dec, 11 is undec, now 12 is dodec, okay? just so you know. So this is all single bonds on this parent chain. So we know this is going to be dodecane is the name of the parent chain. So now let's look at these substituents. So this first substituent here at carbon number 5, there's the connecting carbon. Here's the attachment carbon. And then it has one carbon on one side splitting off and two carbons on the other side splitting off. So is that an iso? No, not an iso, because an iso has to be symmetrical and it has to be that fishtail. So it can only have like a carbon on each side, say at the split. So it's not iso. But what's going on here? But what's going on here with the attachment carbon? The attachment carbon is carbon number 1, 2, 3 out of 3, 4 carbons in the substituent chain. So since the attachment carbon is carbon number 2 in the substituent chain, then 2, it's the second carbon. So that means we're going to call it sec. So we know at carbon number 5 on parent chain, we're going to have a sec and then hyphen butyl. Now next down the parent chain, we have carbon number 7, which is another connection point, and it's connected to this attachment in the substituent. And this attachment has one carbon sticking out on one side, and then 1, 2, 3 carbons sticking out on another side. So now what do? Well, first, we know it's going to be 7 hyphen something because that's the number carbon on the parent chain. But do you see how this is still attached at carbon number 2 in this substituent chain? See, here's the attachment. And so carbon 1, carbon 2, carbon 3, carbon 4, carbon 5 in this substituent chain. And then it's attached up here to the parent chain. So this attachment carbon is still carbon number 2, which means second. So it's still secondary. So we're still going to call it sec. So for this 7 dash from the parent chain, we're going to go sec hyphen, and then this substituent has 5 carbons in it, so that's pentyl. Okay, so now we need to alphabetize these. Well, we have a B and a P, because since they're hyphenated from the sex, we don't use a secondary prefix to use to abbreviate. So we know the butyl is going to come first, so we're going to write this 5 dash sec dash butyl dash 7 dash sec dash pentyl dodecane. So that would be number 5 on this page. Okay, now the bottom left hand, this is number 6. We're going to find our parent chain. So if we start down here, we have 1, 2, 3 carbons before the carbon where it splits. Or if we do it up here, we have 1, 2, 3, 4. All right, so we're going to use that as a part of the parent chain. It's got more carbons. And then it continues on. Here's another split. And if we go down, we just get 2 more carbons in the chain. Or we can go horizontally to the right and get 3. So that's what we're going to do for the parent chain. Now we're going to number this parent chain. So the substituents get the lowest number possible. So 1, 2, 3, 4. If we were to start over here, we get 1, 2, 3, 4, 5. So that's not going to work. And then we continue on. Here's 5. This 4 is a connecting carbon to a substituent. And then this 6 splits off. And then 7, nothing happens. 8, nothing happens. 9, nothing happens. 10, nothing happens. Okay, so we know it's 10. So we know this is going to be a decane, right? Now let's look at the substituent at the 4th carbon on the parent chain right here. So we're going to have a 4 hyphen because this is going to happen at the 4th carbon on the parent chain. Now here is the attachment carbon for the substituent, and then that's attached to 3 other substituent carbons. So what nickname do we should give that? We say tert, right? Because tert is all about what's going on at the attachment carbon. So at the attachment carbon, it's attached to 3 other substituent carbons, and 3 is tertiary. So we have 4 hyphen tert hyphen, and then 1, 2, 3, 4 carbons in the substituent. So this is butyl. And now let's go over to carbon number 6 in the parent chain, the connecting carbon. Here's, we know we're going to have a 6 hyphen. And then here's the attachment carbon right here in the substituent. But nothing branches off from that attachment carbon, does it? No, it goes down to another carbon. And from that carbon, it's connected to 3 different carbons. So now what? Well, if you think you want to call it tert, think about it a little bit more, because the tertiary is all about what is going on with the attached carbon from the substituent that attaches directly to the parent chain. Okay, all this busyness, this doesn't have anything to do with the attachment carbon that's connected directly to the parent chain. This is at the end of a long chain. So what kind of prefix are we supposed to give stuff that deals with the end of the chain and not the attachment carbon in the substituent? So this would be neo. So instead of tert, it would have to be a longer chain, and then that tert shape, that chicken foot shape, would have to be at the end of a long chain, not just directly attached to the parent carbon. So this would be at parent carbon number 6 hyphen, and we would go neo butyl, because when it's dealing with the end of the chain, we don't hyphenate it from the butyl. It all becomes one thing. Okay, so now we have the 4 tert-butyl, and we have the 6 neo-butyl. So now we need to alphabetize to know which goes in what order. We have a B here. Remember, we don't use tert to alphabetize because there's that hyphen there. But there's no hyphen here. Neo becomes part of the whole word. So we use the N to alphabetize. So butyl's going to go first in that case. So we're going to call this 4-tert-butyl 6-neo-butyl decane. So that's how you would name this molecule. All right, so last one, number 7. Let's find the parent chain for this first. Okay, here's a split right here. And this will give us 1, 2, 3 carbons in the chain versus 1, 2, 3, 4 carbons in the chain. So we're going to take this one. And then we go on some more. And this splits, and we could go 1, 2, 3 more carbons, or we could go 1, 2, 3, 4 more carbons, or we could go 1, 2, 3 more carbons. So I'm going to take the one with the most carbons. We know that this is all single bonds as a parent chain, so we know it's going to end in ane. So let's number the parent chain so we get the lowest numbers for these substituents. So we have 1, 2, 3, 4. Here's a connecting point. And then 5 is another connecting point. And then 6 is another connecting point. And then 7, blah, 8, blah, 9, blah, 10, blah. Okay, so 10, we know that's going to be a decane now. And let's go to this first substituent right here, 4, at carbon number 4 in the parent chain. Here's the attachment carbon right here of the substituent. And then it's attached to 3 other carbons, isn't it? So what would this be called? This shape be called again? Tert, right. And since it's 1, 2, 3 attached to 1 attachment carbon, so that's 4. So that's going to be tert-butyl. Oh, and this happened at 4 on the parent carbon chain. All right, what about the next one? Number 5, carbon 5 on the parent chain. Well, here's the attachment carbon for the substituent, okay? And so we know we're going to have a 5 hyphen because that's the number on the parent chain where this is taking place. 5 hyphen. Okay, here's the attachment carbon. And how many carbons is that attachment attached to in the substituent? Well, 1, 2, 3. It's still only attached to 3 other carbons in the substituent. So this would also be counted as tert because it's about the attaching substituent carbon only being attached to 3 other substituent carbons. So that's, by definition, that is tert. So let's put a hyphen there. But that doesn't mean there's only 4 carbons in this because, see, we got 1, 2, 3, 4. And then we got another one coming out, making this middle chicken finger a lot longer, doubly long. So see, here's our chicken hand, right? Our chicken fingers. And a normal tert, that's butyl, which is 1, 2, 3, 4 carbons in the substituent. But we can also have a really long finger coming out there, making that 5 carbons in the substituent. Because what's important to make sure that it's tert is that it's the attaching carbon that attaches to the parent strand is what needs to be bonded to 3 and only 3 carbons in the substituent. And one of those carbons is bonded to another carbon, fine, it's still tert. So this is a 1, 2, 3, 4, 5 carbon substituent, which means a pentyl. Now let's move on to the next carbon in the parent chain that's a connecting carbon, and that's 6. And here is the attachment carbon in the substituent, and that is attached to another carbon, and that carbon turns into a chicken hand and is attached to 3 substituents. So when you're dealing with just the end of a long chain in a substituent, this is no longer tert because this isn't really attached to 3 substituent carbons, is it? It's attached to 4 because it's attached to this one up here and these 3 down here. And the attachment carbon is not attached to 3 other carbons. It's only attached in the substituent. It's only attached to this one where everything splits. So it's not tert. This, when it's a chain and we're worried about what's at the end of the chain, and it's a chicken foot, and that's called neo. So at carbon number 6 on the parent chain, you're going to have hyphen neo, and this is 5 carbons in the substituent as well. And we're just going to run this all together, no hyphen, neopentyl, because tert and sec get the hyphen because they're talking about what's going on at their attachment carbon in the substituent. Neo and iso don't get a hyphen, and they get to join in on alphabetizing and everything because they're talking about the shape at the very tail end of the substituent chain. So now that we have all these together, let's put these all together. We need to alphabetize these, and we can't use the T for tert, so we're going to use a butyl. We can't use T for tert here, so we use a P for pentyl. But then on carbon 6, we can use the N instead of the P for pentyl because it's neo, because it's concerned with the very tail end of the shape. So very first is going to be B for butyl. So 4 hyphen tert hyphen butyl, and then hyphen, what comes next? N, so that's 6 hyphen neopentyl hyphen 5 hyphen tert hyphen pentyl decane. So that is going to be this. And don't worry, as I said, I'm giving you tricky ones. I'm trying to give you really tricky, complex ones. So you're prepared and you're not just used to doing the really simple, easy ones. And then you get into class or you get into your test and, oh no, I didn't study this. So I'm trying to give you the tricky ones. So if you can do these, you're going to be okay.